Question 20. The histogram shows information about the times taken by 160 cyclists to complete the Tour de France cycle race. So our frequency density here in our histogram we've been given the values as so, and our time intervals or time values are here that allow us to get our intervals based on the different widths of each of these bars. 6 cyclists took less than 85 hours. What that's telling us is that this bar here, which is the only one less than 85, is telling us that the area of this graph is, or the area of that bar is 6. Work out an estimate for the number of the 160 cyclists who took less than 86 hours. So, they've given us the frequency density already here, so I can read off this that that's 12, and I can see that our width of our bar is 0.5. So it's interesting that they give us this information here in blue, because technically if I do 0.5 times 12, then I will end up with 6. So I'm kind of wondering why they've actually given us that. But in any case, we're given that 6 cyclists. Work out an estimate for the number of the 160 cyclists who took less than 86 hours. So less than 86 hours is going to be everything I'm about to shade now in yellow. Nope, that's not shading. Everything I'm going to shade now in yellow. In fact, I've just realized as well why they've actually given us that information in blue, because you can get technically histograms where the area isn't actually the frequency. It could be a scalar, it could be a multiple of, like if I ended up with this area as being 60, then that would just tell me that whatever I get as my frequency, the area will be 10 times bigger than it. You could technically get that, but most of the time the area will match your frequency density. Anyway, the area of the yellow bit, we're going to break them up into the 3 bars. So we've already got the 6 here. We find the area of each of the other 2 bars, which we'll get by doing 0.5 times 20 for the middle bar, and we're going to have 0.5 times, that will be, 16. And then we're going to add our 6 to that, and we will end up with 24. So 24 cyclists is going to be our estimate for that. The reason why it's an estimate is because of the fact that technically we're assuming that half of the cyclists in this bar are to the left. But of course, technically, this bar is between 85.5 and 86.5. So although it looks like it's evenly distributed, there's no reason to say technically that all of the cyclists in this bar, maybe they all took 86.9 and 86.4 even. So that's why we have estimate for that question. Part B. For these 160 cyclists, work out an estimate for the time taken by the cyclist who finished in the 50th position. So the 50th position, we are looking for, we need to look at the number of cyclists that are in each of these bars up until a point where we feel we can have a total of 50 cyclists being in this area. So obviously 24 took us up to there. We need to keep going with these bars until we get a point where we can say, you know what, here is going to be where our area in total, the red shaded bit, is 50. So we keep finding the areas of bars until we get close to our total of 50. We have 24 cyclists based on what we've shaded so far. So if we keep going with that 24, I can add another, what was it we had, a 0.5 times 16 for this bit. So that's 8. We can add another 8 for this bar here. So we add 8, that takes us up to 32. So the first 32 cyclists, or the 32nd cyclist, would have finished with a time of 86.5. We can then explore the area of this bar here, which will be 0.5 times 36. So 0.5 times 36, which will give us an 18. And luckily, when we add these together, that's going to give us 50. So the area of this part here is 18 And by the time we add that 18 cyclists in there onto the 8, onto the 8, onto the 6, onto, what was the other one, 10, that's what it ended up being here, then that gives us a total area over all of these sections as being 50. Therefore, predicting the time for the 50th cyclist is 87, I don't know if I said minutes before, but I meant to say hours, 87 hours. Now, let's just say that that wasn't 18. Let's just say that that was a number that was smaller than 18. Let's say it was 12. Then that would mean that if this was 12, I wouldn't have yet reached 50, and so I would have to keep looking to the left. Now, I was going in chunks of 5 bars, 5 mini squares in a row. But if it got to the stage where we're really close, we could start looking at the area of one thin strip there, then maybe the area of another thin strip, and kind of go up in smaller increments from that. Conversely, if I'd gone too far, let's say that this wasn't a 12, this wasn't an 18, let's say it was a 24, so I'd gone 6 too far, I would have been up to 56, then I would have had to have started looking back the way, so I wouldn't have been at 87, I would have been slightly back, and I could take away one sliver of area like this, and then the second one, I keep kind of breaking it down into smaller increments. Alas, it worked out perfectly in the end. That's more luck than anything else. 87 hours is our prediction, our estimate, and that's that question done.